This video is about using CPCTC to prove corresponding parts are congruent. So what does CPCTC stand for? It stands for corresponding parts of congruent triangles are congruent. So what we can do is we can prove that two triangles are congruent. Remember when we prove that triangles are congruent, we need three pieces of information. And then after that, the other three pieces are also known to be congruent because the triangles are congruent. So first we're going to determine how the triangles are congruent. We're going to write a congruency statement and then show what else we know must be congruent. So in number one, we also know that AS is congruent by reflexive property. So we used side angle side to prove the triangles are congruent because we have two sides and the right angle is touching both sides. So we make a congruency statement. We have triangle CAS is congruent to triangle RAS. Remember, order is important with the corresponding pieces. Now, when it says what else is known using CPCTC, we need to show things that are not currently marked that are also congruent. So one of those would be angle C and angle R. We also have these two angles at the top. Now, we're not going to name them 1 and 2. We're going to use 3 letters to name them. So we have angle CAS is congruent to angle RAS. And lastly, we know that CA is congruent to RA. Number 2, in this triangle, we also have reflexive property again. So EL is congruent to itself. So in this case, we have a right angle the side across from it and one of our legs. So this would be HL. So our congruency statement could be that triangle BEL is congruent to triangle UEL. And then we need to know 3 other things that are not marked congruent. So right now we know that angle B is congruent to angle U. We know that angle BEL, the angle at the top, is congruent to angle UEL. And we know that BL is congruent to UL. Number 3, in a bow tie problem, remember that you can always also mark vertical angles are congruent. So in this case, we used angle side because the side is only touching one of our angles. So angle side. When we name our triangles, be careful here. So the first triangle, doesn't matter how we name it, so we'll just name it HEA is congruent to. Make sure that your angles are matching up. So in the second triangle, we would have TRA. What other pieces are known to be congruent? So what else did we not mark? We didn't mark that E is now congruent to R. HA, which is the first and last letter of the first triangle, is congruent to TA, and EA, the second and third letter, are congruent to RA. Number 4, looking at the triangle, we can also mark again vertical angles because it's a bow tie problem. This time we have angle side angle because the side is touching both angles. So we have triangle WTR is congruent to triangle EIR. And now that we've done that, we can use CPCTC. So we know that angle W is now congruent to angle E. WT is congruent to EI. And WR is congruent to ER. So now we're going to use CPCTC in our proofs. So the difference from the proofs we've been doing with now using CPCTC is that the proof statement does not say prove triangles are congruent. It'll either tell you an angle or a side is congruent. So we have to go one step further than we've been going in our proofs. We still have to prove the triangles are congruent first though. So we're going to do all that work first. So if C is the midpoint of AE is bisected into two congruent parts. C is the midpoint of BD, so BD is also bisected into two congruent parts, and it's a bow tie problem, so we have vertical angles are congruent. So now we know that we're going to prove our triangle is congruent by side angle side, so we're going to start our proof. Remember, all proofs start with the given statement. So C is the midpoint of AE and BD, which is given. So in step 2, we're going to say that AC is congruent to CE. And in the same step, we can also say that BC is congruent to CD because they use the same reasoning. So the reason that those are congruent is that a midpoint bisects a segment into two congruent parts. Then we also have vertical angles are congruent. So angle 1 is congruent to angle 2 because vertical angles are congruent. And then our second to last step is we prove that the triangles are congruent. So they didn't give us the triangle name, so we have to make them. So triangle ABC is congruent to triangle EDC. And we know that was from side angle side. So now this is where we usually stop our proofs, but because it says prove the angles are congruent, we're going to go one more step. Angle A is congruent to angle E by CPCTC. Number 6, given that RA is congruent to IA, AN bisects angle RAI. So when an angle is bisected, it's bisected into two congruent parts. It doesn't deal with the opposite side, it just deals with the angle. And then we also have reflexive properties. So again, this is a side angle side proof. So we're going to write our givens first. RA is congruent to IA or AI, and AN bisects angle RAI. That was given to us. So now that we know the angle is bisected, we can say that angle 1 is congruent to angle 2 because an angle bisector bisects an angle to two congruent parts. And then in our third step, the other thing that we also marked was that AN is congruent to AN by reflexive property. Now that we have three pieces of information, we can prove that the triangles are congruent. So triangle RAN is congruent to triangle IAN, and we said by side angle side. And then our last step is that proof statement. So step 5, RN is congruent to IN by CPCTC. Number 7, this is now a flow proof, and we're doing the same thing. So notice with the flow proof, our last statement is still that proof statement over here. So I is the midpoint of PN and of OA. So in this case, we need to write down the same box, and then we're going to split into two steps to show each of these things are congruent. The other thing we can also mark in our triangle is that vertical angles are congruent. So all the way to the left over here, we're going to give our given statement because it has to break into one more step each. So I is the midpoint of PN and OA, and that was given to us. So we know that PI must be congruent to NI, and OI is congruent to OA. Since this is the same step, I'm just going to write in the middle that it applies to both steps. So midpoint bisects a segment into two congruent parts. If I want to show that that goes to both, I'm just going to make two arrows so I know it goes to both proofs. Then the other thing we also marked was that angle 1 is congruent to angle 2 because vertical angles are congruent. Then I need to show that my triangles are congruent. So now that I have those three boxes pointing to the same box, triangle POI is congruent to triangle NAI by side angle side. And the last step would be our given, which was already typed in, by CPCTC.